Well, this video is for Math 95, and we're going to go over an assignment on solving radical equations. And before we start, let's talk a little bit about computation. All right. So I like to talk about this as a hierarchy of computation. You've got addition and its opposite subtraction. You've got multiplication and its opposite division. And you've got exponents and their opposite, which are roots. And in the same way that you can solve an equation, let's say you've got, 3x equals 12. The 3 is getting multiplied by the x, so we do the opposite, dividing by 3 on both sides to get a solution. In the same way that we do that, we can, and we saw in an earlier assignment where we had something like x to the 5th power equals 1,000, we could undo that exponent by taking a 5th root on both sides. The 5th root undoes the 5th power, and over here we calculated a 5th root of 1,000, whatever that might be. Okay, so in the same way that you can undo an exponent with a root, we can undo a root by raising it to a power. So if we had something, let's just do something simple, square root x equals 7, we can undo this root by squaring both sides, and that'll tell us x equal to 49. Okay, so that's the idea or the concept that we're going to be applying in solving these equations. So let's take a look at a couple of these. Problem 2 is pretty straightforward. We've got a square root of 2x minus 1 equal to 5. Now this first problem, like I said, starts out pretty simple because the square root piece is by itself. And that's what we want to do, is we want to have that square root piece by itself, and then once we do, we can square both sides. This will just be 2x minus 1. And now that's 25. And now we just solve this like a regular equation, add 1 to both sides, 2x is 26, and divide on both sides by 2, and there's our answer, x equals 13. Okay, let's see here. And now problem 3 has an issue that problem 2 doesn't, and problem 4 doesn't as well. So I'll make up a different example here that's like number 3. So let's say we had something like 7 plus the square root of y minus 4 equals 15, or something like that. And so this added piece here, we could square both sides, right? It's just like I was just showing Math 60, how when you're solving an equation and you've got something like 5x minus 3 equals 14, I like to add 3 to both sides and then divide by 5. Now there's nothing preventing us from dividing on both sides by 5 to begin with. It's just that most people have real difficulty with this over here, because what we're doing is we're distributing this dividing across the subtraction. In the same way that we can distribute multiplication over addition or subtraction, we can also distribute the dividing. But people often have difficulty with that. That's why I say it's usually best to add the 3 over and then divide by 5. Same thing here. What I'm going to do is I'm going to subtract 7 on both sides, and then we'll have square root y minus 4 equal to 8. Now the square root's by itself, and we can just square both sides cleanly, and then add 4, and we get y equals 68. Okay? Now, we don't have to do that. Okay? I mean, I like to talk about these things because I don't want people to get the impression that you don't have choices, that you have to do everything the way that I demonstrated. And I always tell people the way that's easiest for you is the best way to approach problems. Okay, so what if we didn't move the 7 over? What if we just squared both sides? Well, the trap that people fall into here is they try to distribute the exponent across the addition. And I think we've talked about why that doesn't work. You can distribute one level of computation, but not two, right? You can distribute multiplication and division across addition and subtraction. You can distribute exponents and roots across multiplication and division, but you can't try to distribute this exponent across addition or subtraction. It's not going to work. If you wanted to square this thing, you'd have to literally multiply it by itself. And this just creates a mess. You get 49 plus 14 square root y minus 4 plus y minus 4. And the whole goal of squaring both sides is to get rid of that square root. This doesn't do that. See, we've still got the square root in there. Okay? So that's why I recommend getting that square root by itself as a way to get started before you square both sides. So that's what I'm going to be doing for the rest of these problems. Let's see here. So let's look at problem 6. Problem 6 doesn't have that issue, and in fact most of the problems on this assignment don't have that issue. But we'll have a second assignment where that will come up more often. So this one, let's see, we've got 4x squared plus 3 under the square root, and then 2x minus 3 over on the other side. Okay, so the square root is by itself. That's good. That's what we want. So this will just come out as 4x squared plus 3. Now over on the other side, you've got to be careful again. Don't think that this is going to be 4x squared minus 9. It's not. Okay? This is going to be 2x minus 3 times 2x minus 3. That'll give us 4x squared. Let's see, minus 6 and minus 6 makes minus 12x plus 9. Okay, let's see here. Subtract the 4x squared, and the x squareds drop out. That's good. That makes this an easier problem to solve. Now we just subtract 9 on both sides. Negative 6 is negative 12x. Divide on both sides by negative 12. And x is 1/2. You can call it 0.5 if you want to. Either way, that's the answer. Okay. So that's problem 6. Let's look at problem 8. Problem 8 is a trick problem. 7 and 8 both have the same trick in them, and it's something that I'm not a great fan of, and I'll explain to you why in just a minute. For one thing, I don't particularly care for trick problems, but because they're out there, I feel responsible to let people know about them. So here's the trick. In American mathematics, when you write something like square root 5, that means only the positive square root of 5 and not the negative square root of 5. And I actually once taught at a boarding school where we had some students from Taiwan, and they had been taught over and over again, their teachers had made sure that they understand square root means you've got to think about a positive or a negative square root. Let me give you a perfect square example of this. Square root 9 in American mathematics means only the positive square root of 9, which is positive 3. Now, outside of the United States, people consider both the positive and the negative square roots of 9 because, right, if you think back to what a square root is, 3 squared is 9, negative 3 squared is also 9. So both positive and negative 3 are square roots of 9. Okay? But in American textbooks, you'll continually see this issue come up. Okay? So because of that issue, and if you look at this problem, if you think that there is a hidden plus sign out there, then there's no way that this could be negative 7. Now, if we squared both sides, we could come out with an answer. Okay? And I don't really have a problem with that. You know, I don't see that this is such a big issue. I think that it's valid to consider both a positive and negative square root. But just to let you know that there are a lot of people who focus only on the positive square root, and so as a result, the answer to this problem becomes no solution. Because if we're only talking about the positive square root, then it can't be negative 7. All right, so problems 7 and 8 are just an introduction to that concept. Most textbooks don't get into this explanation. All they tell you is, oh, it's only the positive square root. They don't either recognize or know or acknowledge that outside the United States, most people consider both positive and negative square roots. So, in any event, that's something I like to think about mathematics. Some things are conceptual and they're either right or wrong. Other things have to do with notation and the way that people represent ideas, and that's kind of social, political, whatever people agree on, consensus, and that has less to do with mathematics than it does a society or a community agreeing on something. Okay, so that's problem 8. So problems 10 and 12 are regular, straightforward radical equations. So in problem 10, we start out square root 9 minus x equals x minus 7. So this one is very much like problem 6. And what we need to do here is square both sides. That square root's by itself, so we can just square both sides. This one comes out just as 9 minus x. And don't forget over here, you've got to multiply x minus 7 times itself. And so we get x squared minus 14x plus 49. And let's see, we'll add the x over here and subtract the 9 over here. So these cancel out and give us 0. And this will be x squared minus 13x plus 40. And then we need to factor this, right? Solution by factoring, like we saw earlier. And this one's relatively straightforward, okay? 8 times 5 is 40. 5 and 8 make 13. This is negative, so you want these both to be negative as well. So x minus 8 could be 0, which means x equals 8. Over here, x minus 5 could be 0, so x would equal to 5. Okay, so there's problem 10. Yeah, I think I've got enough room to do problem 12 over there. Problem 12, we've got square root 1 minus x equal to x plus 5. So, same process for solving this one. We want to square both sides. This will be 1 minus x. And this will be x plus 5 times x plus 5, which is x squared plus 10x plus 25. And just like we did in problem 10, we're going to add the x over here and subtract 1. This will be 0, and we'll have x squared plus 11x plus 24. And this one also factors pretty simply too, right? This is x plus 3 times x plus 8. And so now we get solutions here. X could be negative 8, or x could be negative 3. Okay, so that's it for this first assignment on solving radical equations. We'll have a second follow-up assignment that's a little bit more complicated than this. So please work through these problems first, and then we'll look at the more complicated ones on that second handout. And if you have any questions, please let me know. Thanks.